Mars has fascinated humans for centuries. It's close enough to study in detail, similar enough to Earth to raise big questions, and different enough to remind us how fragile planets can be. Let's take a deeper look at the red planet, what it is today, and why it matters. Mars is the fourth planet from the Sun, just beyond Earth's orbit. It's about half Earth's diameter, with only 38% of Earth's gravity. The weaker gravity affects everything, from how the atmosphere behaves to how long water can stay on the surface. If humans ever lived on Mars, this low gravity will be one of the biggest challenges to adapt to. Mars does have an atmosphere, but it's incredibly thin, less than 1% of Earth's surface pressure. It's mostly carbon dioxide with traces of nitrogen and argon. That thin blanket offers little protection from radiation and can't hold heat well, which is why Mars is cold and dry today. Average temperatures hover around minus 80 degrees Fahrenheit. Mars gets its red color from iron oxide, rust, coating the planet's surface. That rust forms when iron reacts with oxygen, often in the presence of water. So the color of Mars isn't just cosmetic, it's evidence that water once played a major role in the shaping of the planet. Mars is home to some of the most extreme features in the solar system. Olympus Mons is the tallest volcano we know, nearly 3 times the height of Mount Everest. Valles Marineris is a canyon system stretching over 2,500 miles, deeper and longer than the Grand Canyon. These features formed because Mars lacks plate tectonics. Once magma rises, it piles up instead of being recycled. Today, liquid water can't exist on Mars for too long, but signs of ancient rivers, lakes, and possible oceans are everywhere. Ice still exists at the poles and beneath the surface, locked away in frozen soil. Mars wasn't always dry, and that's one of the biggest clues scientists are still investigating. Mars looks quiet now, but it carries the scars of a very active past. Mars wasn't always the cold, dry world we see today. Long ago, it had many of the ingredients needed for a more active planet. So what changed? Let's look at what Mars lost, and why it mattered. Early in its history, Mars likely had a molten core and a magnetic field, much like Earth. The magnetic field would have helped protect its atmosphere from the sun, but Mars is smaller than Earth and it cooled faster. As its core cooled, the magnetic field weakened and eventually faded away. Without that protection, Mars became vulnerable to space weather. With no strong magnetic field, the solar wind began to strip away Mars's atmosphere into space. Over millions of years, the planet lost all of its air. As the atmosphere thinned, it could no longer trap heat effectively. Temperatures dropped, pressures fell, and liquid water became unstable on the surface. Mars didn't suddenly die, it slowly faded. As the planet cooled and pressure dropped, surface water either froze or escaped into space. Some water remains today, locked away as ice in the poles and beneath the surface. But rivers, lakes, and possibly even shallow seas vanished. The planet crossed a threshold it couldn't come back from. Mars didn't fail because it was too different from Earth. It failed because it was just a little smaller and a little weaker and just a little less protected. In planetary science, small differences can lead to very different outcomes. Mars looks dead, but dead is doing a lot of work there. Even today, Mars still has an atmosphere. It's just thin. Thin enough that water can't stay liquid for long, but thick enough to create weather, clouds, and massive dust storms that can wrap around the entire planet. Mars also still has water. Not oceans, not rivers, but ice. Locked in the polar caps, buried underground, preserved like a fossil record of wetter past. And that's why scientists care. Mars is one of the few places where we can clearly see what a planet used to be and what it became. Its surface hasn't been erased by plate tectonics or heavy erosion like Earth. Mars keeps its scars. That makes it a natural time capsule. Rovers aren't just driving around taking selfies. They're looking for minerals that only form in water. They're drilling into rocks that haven't moved in 1 billion years. They're trying to answer very specific questions. Did Mars ever have the right conditions for life, even briefly? Not, was there a Martian civilization? Not, can we live there? Just, was it ever possible? Mars also helps us understand Earth. By studying how Mars lost its atmosphere and water, scientists learn what protects our own planet, and what could go wrong if those systems fail. In a strange way, Mars isn't about the future, it's about context. It shows us how fragile habitable worlds are, and how small changes can snowball, and how rare it is for everything to line up just right. Mars isn't exciting because it's alive, it's exciting because it almost was. And sometimes, almost tells you more than success ever could.